Introduction: Robotic design, construction, and use of machine to perform tasks done traditionally by human beings. Robots are widely used in such industry as automobile manufacture to perform simple repetitive tasks, and in industry where work must be performed in environment hazard to humans. Why robots are created? The goal of robotics is to design machines that can help and assist human. Robotics integrate field of mechanical engineering, electrical engineering, information engineering, mechatronic, electronic, bioengineering, computer engineering, control engineering, software engineering, and mathematics. Law of robotics defined by Isaac Asimov. The first law: a robot may not injure a human being or through inaction allow a human being to come to harm. The second law: a robot must obey order given to it by human being, except where such order will conflict with the first law. The third law: a robot must protect its own existence as long as such protection does not conflict with the first or second law. Function of robot. Industrial robots often have movable robotic arms. The amount of movement in robot is called the degrees of freedom. Many robotic arms have an effector attached on the last joint. They are all sort of an effector that are set to particular application. One common end effector is called a gripper. Grippers are capable of grasping, holding, and controlling objects. Some robots have a hand with built-in pressure sensor that indicate how hard a robot is gripping an object. And effectors are also tools capable of performing physical action such as cutting, painting, or drilling. The operation of a robot is depend on sensor, actuator, computer control, and software program. Robot terminology. Link and joint. Link are the solid structural members of a robot, and joint are movable coupling between them. 2. Degree of freedom is the number of independent movement the robot can realize with respect to its base. 3. Accuracy. How close the arm will be when it moves to the desired point. And 4. Precision. How accurate a specified point can be reached.
So I will talk about comparison between a robot and an automatic machine. Robots are made to perform several jobs at once. At the switch of operation can be swept around to make the process more efficient. The timing of the operation also can be changed if needed. And robots are made to reactive something blocks or stop the robot. It will change the operation to best fit the situation. And robots can be made with intelligence, and they are able to learn from mistakes. This is allowed the robot to fix problems if it is exposed to them long enough, and can work faster and is able to accommodate complex movement. Automated machine can be only follow one set of operation, and it cannot be changed on programming. The automated machine will not reach even if there is an object blocking the automation. It will continue doing the same operation and unable to collect knowledge and can be programmed with any form of intelligence, and work slowly and are typically programmed with very simple movement. I will talk about 4 robotic devices not considered an industrial robot. First, domestic or household robots. Robots used at home. This type of robots includes many different devices such as robotic vacuum cleaners, robotic floor cleaners, sweepers, gutter cleaners, and other robots that can do different chores. Also, some surveillance and telepresence robots could be regarded as household robots if used in that environment. The second is medical robots. Robots used in medicine and medical institutions. First and foremost, surgery robots. Also, some automated vehicle and maybe lifting aids. Thirdly is scientific robots. Robots that do not fall into other types by usage. This could be different data gathering robots, robots made to show off technologies, robots used for research or data gathering. So, for the last robotic device, not an industrial robots, is military robots. Robots used in military. This type of robots includes bomb disposal robots, different transportation robots, reconnaissance drones, often robots initially created for military purpose can be used in law enforcement, search and rescue, and other related fields. Capability of industrial robots. The use of robots improves efficiency and accuracy on a variety of applications. Robots are controlled by a computer. They save time and money as they replace human labor for hazardous or repetitive tasks. Since they are never grow tired, they can work long hours in harsh environment. Applications such as assembly, welding, painting, product inspection, picking and placing, die casting, drilling, glass making, and grading are all accomplished by robots. Many industries rely heavily on robots, including aerospace, automotive, consumer goods, electronic, metals, food and beverage, foundry, medical, military, pharmaceutical, and plastic and wood. Advantage of industrial robots. First, quality. Robots have the capacity to dramatically improve product quality. Applications are performed with precision and high repeatability every time. This level of consistency can be hard to achieve any other way. Number 2 is production. With robots, throughput speed increase which directly impact production because robots have the ability to work at constant speed without pausing for breaks, sleep, vacation. They have the potential to produce more than human workers.
Disadvantage of industrial robot. Expense. The initial investment of robot is significant, especially when business owner of limiting their purchase to new robotic equipment. The cost of automation should be calculated in light of business greater financial budget. Regular maintenance need can have a financial toll as well. And return of investment (ROI). Incorporating industrial robot does not guarantee result. Without planning, companies can have difficult achievement their goal. Function of robot. Advertised employee will require training in programming and interacting with the new robotic equipment. This normally takes time and financial output. Safety. Robot may protect workers from hazard, but in meantime, they very present can create other safety problems. This new danger must be taken into consideration. Industrial robot component. First is robot manipulator. Second is robot controller. And the third is robot end effector. The fourth is robot actuator. And the last one, 5, is robot sensor. Manipulator arm. The manipulator are mechanical part of robot system that can be moved into different directions. The result of a combination of movement X. It consists components such as a human arm, of the upper arm and forearm are connected to the base, shoulder, elbow, and wrist. It can carry sensor tips, the end effector, to the required destination. Controller. The controller is the brain of the industrial robot arm and allow the part of the robot to cooperate together. It works as a computer and allow the robot to also connected to other systems. The robot arm controller run a set of instructions written in code called a program. The program is input with a touch pendant. And the last one is many of today industrial robot arm are use interface and assembly or it's built on the Windows operating system.
Next is end effector. The end effector is a equipment installed on the end of the outlet processor, which operates under the duties to be performed. Two types: grippers to grasp and manipulate object during work cycle, and number 2, tools to perform a progress like a spot welding and spray painting. Some variation of the end effector are gripper like a vacuum pump, a magnet, and a welding torch. Some robots are capable of changing an effector and can be programmed for different set and tasks. Next is actuator. The actuator are used in a robot for providing the power of the robot joint. It can be powered by any one of the following source. Number 1, hydraulic, number 2, pneumatic, and number 3, electric. And then hydraulic drive system give a robot great speed and strength. A pneumatic drive system are used for smaller robot and have few X of movement. An electric system provide a robot with less speed and strength. The third part is a sensor. A sensor allow an industrial robotic arm to retrieve feedback about environment. The sensor collect information and send it to electronically to robot controller. One use of this sensor is to keep two robots that work closely together and from bumping into each other. Sensor can also assist an effector by adjusting for part variance. Vision sensor allow a pick and place robot to differentiate between item to choose an item to ignore. Robot joint and motion. Robot joint is a mechanism that permit relative movement between parts of a robot arm. The joint is the joint of a robot designed to enable the robot to move is an effector along a path from the one position to other as desired. The basic movement required for motion industrial robot. Number one, rotational movement. This enables the robot to place the arm in any different on a horizontal plane. Number two, radial movement. This enables the robot to move its end effector radially to reach distant point. And number three, vertical movement. The enables to take its end effector to different height. And then 6 degrees of freedom. Rotational traverse is movement on a vertical axis. This is the side-to-side swivel of the robot arm on the base. Number two, radial traverse is an extension and rotation of the arm, creating in and out movement relative to the base. Vertical traverse provide up and down motion. Pitch on bend is the up and down movement of the wheels. Yaw is the side-to-side movement of the wheels. Rod and swivel is a rotation of the wheels.